we are going to discuss transformation, and this is one of the methods to sketch the graph of the given function. Now, we know that there is this table of values that we usually use to sketch the graph of the given function. But using table of values is quite time consuming, so here is another method, but there are rules to follow in this method. Okay, so one of the requirements to use this transformation method is our knowledge on familiarizing the basic functions, or shall we say the parent functions that we already discussed in the previous videos. So first, the horizontal shifting of graphs. Now the rule says that suppose C is greater than 0, which means we have a constant C which is positive. Now, to graph y is equal to f of x minus c, now this function here is a composite function, okay? A function of another function. Now, all we have to do, if you are given a function of this form, all we have to do is to shift the graph of y is equal to f of x to the right c units. So, it's very important to know the graph of y is equal to f of x first for us to know the graph of this composite function. Okay, take note, if the function is of this form, x minus c, all we have to do is to shift the graph of f of x c units to the right. Why is it c units to the right? Because we have f of x minus c, and if we equate this x minus c to 0, the value of our x is equal to c, which means the value of x is in the positive axis. Okay? So the illustration of this rule is this one. So suppose this is the graph of y is equal to f of x, then the graph of y is equal to f of x minus c is this one, the pink one. We only shift this graph to this location here, c units, or to the right. Now, how about the graph of y is equal to f of x plus c, another a composition of function or composite function where this one, the operation inside the another function is positive. So if it is positive, we shift the graph of y is equal to f of x to the left c units. For example, we know the graph of y is equal to f of x, and we are asked to find to sketch the graph of y is equal to f of x plus c. It is x plus c because if we want to know the value of x, we equate this one to 0, then we have x plus c is equal to 0, so x is equal to negative c, which means the direction is on the left side of y is equal to f of x. Okay? So another is this one. We have here, if we have the horizontal shifting, we also have the vertical shifting. Now, when can this happen? Suppose c is greater than 0, then to graph y is equal to f of x plus c, okay? So this is of the form f of x plus c. All we have to do is to shift the graph of y is equal to f of x upward c units. Okay, take note, this is no longer a composite function. The constant c is outside the function f of x. So if it is positive, all we have to do is to shift the basic function or this function c units upward. Okay. Now, the illustration is this one. Suppose this is the graph of y is equal to f of x. To graph y is equal to f of x plus c, all we have to do is to shift this graph c units upward. Okay. So this one, next rule, the graph y is equal to f of x minus c. So this is opposite to this one. All we have to do is to shift the graph of y is equal to f of x downward c units. So for example, this diagram here, suppose this is the graph of y is equal to f of x, and we want to know the graph of f of x minus c. So all we have to do is to shift this graph downward c units. Okay, so another is reflecting graphs. Now, sometimes we can encounter a function like this, of this form. To graph y is equal to negative f of x. So if we know the graph of f of x and there is negative besides the f of x, so all we have to do is to reflect the graph of y is equal to f of x in the x-axis or with respect to the x-axis. For example, in this case, y is equal to f of x, right? And since we are asked to know or to sketch the graph of y is equal to negative f of x, so using this reflecting graphs or this type of transformation, all we have to do is to reflect this graph with respect to the x-axis. Okay? So as you can see here, this distance here to the x-axis is just equal to the distance from this point to this point. Okay, so it's a reflection with respect to the x-axis. Take note of the form. Now, the second one, to graph y is equal to f of negative x. Okay, so the negative is inside. Okay, is inside in, is inside with another function. All we have to do is to reflect the graph of y is equal to f of x in the y-axis or with respect to the y-axis. So for example, this is the graph of y is equal to f of x, and we want to know the graph of y is equal to f of negative x. Okay, so all we have to do is to reflect this graph with respect to the y-axis. So take note that the reflection is this one, the pink one is the reflection of the blue one. So this one, from this point to the y-axis, the distance is equal to the distance from this point to this point. Since this pink one or um, is just a mirror of this graph, or this graph is just a mirror of this graph. So that is reflecting or reflecting graphs. Okay, so we have here examples. Um, for example, we want to sketch the graph of f of x is equal to quantity x plus 2 raised to 5. Now, earlier, I've said that it's very important to know the graph of the basic function. So in this case, the basic function that can be used is the function of x raised to 5, right? Because this is a composition of function wherein we can let this x plus 2 as big X. So we already have a form of x raised to 5. So first, all we have to do is to sketch the graph of the parent function first, or the basic function, x raised to 5. So the graph of x raised to 5, we know that already. It's like a graph of x cubed, x raised to 7, x raised to 9, right? When we discussed um, power functions, and this power function has an exponent which is odd, so the graph looks like x cubed. So um, in this case, in transformation, using transformation method, even if we only have 3 points, as long as we know the form or the shape of the graph, it's now easy to sketch the graph that is similar to the basic function. For example, x raised to 5. So suppose x value is 0, we substitute that one to x raised to 5, the y value is 0. If x is equal to 1, the y value is 1. If x is negative 1, the y value is negative 1. And since we already know the form of the graph of x raised to 5, which is the same as x cubed, so we just connect these 3 points. So even if we only have 3 points, as long as we know the graph, so we connect this one, okay? So this is now the graph of x raised to 5. Now, the main problem is this one. the quantity x plus 2 raised to 5. Now, this is a composite function. We have a function x plus 2 which is inside the x raised to 5 form, right? So, we can apply the transformation method, which is what? Which is the horizontal transformation method. That is what? Shifting horizontally. So since we have x plus 2 here, this is x plus c, the generic formula or general formula. So we equate this one to 0 and we solve for x, so x is equal to negative 2, which means this value here is shifted to 2 units to the left. Okay, so this 0, the x value becomes 2, 0. So take note, the y values did not change because the shifting happened horizontally. Okay, this one, we shift this 2 units to the left, so 1, 2. And this one is 2 units to the left, 1, 2. And again, since this is a transformation, a shifting, the final graph is just the same as the parent function. So we just follow the form of the graph. Okay. So this is now the graph of quantity x plus 2 raised to 5. Okay. Okay. So another example, suppose we have here given function f of x is equal to negative 2 times quantity x minus 3 raised to 4. Okay, so first we have to look at what basic function that can be used in order to solve or to sketch this graph. Now we have a composite function. If we take this x minus 3 as big X, for example, so we have a graph of x raised to 4. So that would be our parent function, our basis. So all we have to do is to sketch the graph of x raised to 4. So if x is 0, y is 0. If x is 1, x raised to 4 becomes what? Becomes 1. If x is negative 1, x raised to 4 becomes 1 also. So, sketching x raised to 4, we have a parabola that looks like this, right? So, but there is negative 2 here. So, all we have to do is just to multiply this negative 2 to every y value of x raised to 4. What is our x raised to 4? Again, the y values, can you imagine? The y value is 0, 0, 1, and 1. So we have two y values. But since we are going to multiply negative 2 to the y values, so the x values here will not change. So negative 1, and the y value in the x raised to 4 is 1. So 1 times negative 2. So this one becomes negative 2. And the y value here, which is 1, becomes negative 2. So therefore, this is the graph of negative 2x raised to 4. Okay? So, we have a graph of negative 2x raised to 4 already. But here, we have x minus 3, right? So, we can have a what? A horizontal shifting that is to the right. How many units? 3 units. Okay, so x minus 3. So x is equal to 3. So all we have to do is to shift this graph 3 units to the right. So we just count this x value, which is 0, count 3 units, so 1, 2, 3. Okay, so we already have 3, 0. Now this value here, the 1, the x value, which is 1, we count 3 units to the right, so 1, 2, 3. So we are now on 4, negative 2. And this point here, negative 1, so 1, 2, 3. So we are now in 2, negative 2. So this is now the final answer, or the graph of y is equal to negative 2 times x minus 3 raised to 4. Okay? So another example, so we have an example which is a combination of many transformation methods or rules. So here, by uh, looking at this function here, we have -3 times the quantity of x minus 2 cubed plus 1. Okay, again. So what would be our basis? Our basis, take note that we have a composite function, um, quantity x minus 2 raised to 3. So we can take this one as, let's say, big X. So we have the form x cubed, right? So since we know the graph of x cubed, so that will become our basis. So all we have to do is to sketch the graph of x cubed. So this blue graph is the graph of x cubed. For example, if x is 0, it's 0. If x is 1, 1. If x is -1, -1. Then connect because we know already the shape of the graph of x cubed. Okay. Now, since there is 3 here, so all we have to do is to multiply this 3 to the graph of x cubed or to the y values of x cubed, right? So, what's the y value here? It's 1. What is the y value here? It's 0. What is the y value? It's -1. So, multiplying that 1 by 3, although we can multiply uh, the y values of x cubed immediately by -3. But in this case, we start multiplying with positive first. So we multiply the y value. The y value is 1 times 3. So which means 1, 3. Okay? So this value is still 0, the y value. And if it is -1, the y value is -3. That's why graph, I sorry, the pink graph looks like this. As you can see, okay, the graph, this one is closer to the y-axis. So this is now the graph of y is equal to 3x cubed. But since there is negative here, so all we have to do is to multiply multiply each y value of this 3x cubed. Okay? Why is it y value? Because the y value is the resulting value after evaluating the current function, which is 3x cubed. Okay, so multiplying by -1, so the y value here, this is now the latest, right? So the y value is 3 times -1, so it becomes -3. Okay, now the y value here is 0, so it's still 0, but the y value here is -3, right? Times negative, it becomes positive. That's why the form of the graph looks like this. Okay, so this one. Okay, notice that this is a reflection of this with respect to what? With respect to the y-axis. Okay, as well as what? The x-axis. Okay, so this is now our graph of -3x cubed. Okay, now, since the original function, it's not x cubed only, but it is x minus 2 cubed, right? So this one, all we have to do is to, applying the horizontal shifting, we shift this one 2 units to the right because we have an inner function which is x minus 2, which means x is equal to 2. So which means the 0 here is shifted 2 units to the right. So 1, 2. Okay. So, and this x value here is shifted 2 units to the right. So 1, 2. And this one, 1, 2. So, this graph is transformed and it is located here, right? is located here. But since there is plus 1 here, meaning the the graph, okay, the graph whose point, or whose the graph that lies on the point um, 2, 0, this will be shifted 1 unit upward. That's why we shift that one 1 unit upward. Then all the y values shift 1 unit upward. So this is now the final answer. Sorry. This is now the final answer of, or the final graph of the given function y is equal to -3 times quantity x minus 2 cubed plus 1. Okay, so that is how we use transformation to sketch the graph of the given function. So hope you like this video, and don't forget to share the learning that you've got from this video. For our next topic, we will be discussing about leading coefficient test. That's another way of sketching a polynomial function. Okay, so again, um, transformation method is very important, and it can be used even if the given function is quite complicated. As long as we know the graph of the basic function, then it will become easier for us to sketch the function that is quite similar, even if it is quite complicated. Okay, so thank you so much, and hope you learned something from this video. Thank you once again, and God bless.